Walker. I'm located in North Platte at the West Central Research and Extension Center, and my talk's going along with Dr. Jim McDonald. He focused mostly on grazing corn residue with calves and growing animals, and my job is to talk about grazing corn residue with mature cows. I'd like to just talk about how abundant of a resource corn residue is in the state, and what a good advantage it gives to cow-calf operators to utilize corn residue during the winter. By far, the most important consideration when grazing corn stalks is the stocking rate, and we'll talk about that. The reason why it's so important is because the different parts of a corn plant differ in their nutrient content, and it's important to set the stocking rate appropriately so that the cows are consuming the most nutritious parts of the corn plant, and so that we move them to a new field before they start eating the less nutritional parts. I want to talk some about how grazing is compatible with modern farming. You know, we need to be concerned about any potential carryover consequences on subsequent corn production or subsequent crop production, and we've been doing quite a bit of research looking at those effects, and it turns out that that's something that we don't need to be concerned about. So grazing is compatible with modern farming, and we don't need to worry about, in most instances, subsequent effects on crop production. So I want to spend a little time talking about animal performance and cost and just demonstrate what a good resource corn residue is for grazing in the winter. Okay, so first I just want to talk about the abundance of corn residue in the state. These are some data that the USDA Economic Research Service collected from a survey back in 2010. And they asked corn producers how many of them utilize corn residue on their farms. And so I've included Nebraska and the surrounding states. And as you can see, a little over half of the farms in Nebraska reported that they grazed at least some of their corn residue, which is quite a bit higher than our neighbors and a lot higher than the average for the U.S. These are some data from that Monsanto collected through a private survey. They're interested in how much of the residue in the state gets grazed. What I'm showing here is the average stocking rate from the respondents to their survey. On average, the average stocking rate in their survey was 0.9 AUMs per acre. And there was quite a bit of variation around that. But and a lot in terms of number of respondents to their survey actually stocked lighter than that. One of the things we'll get to later in the seminar is about that 0.9 AUMs per acre is a really light stocking rate that we can safely stock heavier than that and have good animal performance. So if we take that 0.9 AUM per acre stocking rate and multiply that by the percentage of corn acres that respondents to the Monsanto survey said, which was about 40% of the corn acres are being grazed, that works out to be about 25% of the available corn stover in Nebraska is grazed right now. So if you listen to Dr. Klopfenstein's presentation, he stated that if all the cows in the state plus all the needs for the feedlot were added together, we would need about 11% of the total corn residue that's produced in the state to meet all those needs. And so here I'm saying that currently cows eat about 25% of the stover. What's the difference there? Well, I think the thing to point out is what I'm talking about here is currently cattle are utilizing only 25% of what could sustainably and what we would recommend as a recommended stocking rate. Okay? So It's not that those two numbers are contradictory, it's that they're talking about completely different issues. Dr. Klopfenstein's saying that 11% of the total residue, including all the leaves, the stems, the cobs, and the husk, we only need 11% of that. And the way I calculated this number was by saying that cows are currently only eating about 25% of just the leaves and husks, or the parts of the corn plant that we would want the cows to eat. So that's the difference between those two methods of calculating. And I think that the important point is that corn residue is an abundant resource in the state, and it's currently being very underutilized, and it's an important resource for the beef cattle industry that we should take advantage of. Okay, so what I want to move into next is just some discussion about the difference in the nutrient content of the different parts of a corn plant. What I've got listed here is the crude protein and TDN values for the grain, husk, leaf, cob, and stem. As you can see, so by far the corn grain is the most nutritious part of a corn plant. Next in order of digestibility is the husk, followed by the leaves, which are actually sort of medium quality, and then the cob and the stem, which are low quality. I want to put that together with the relative abundance of each of those parts of the corn plant. And so what I'm showing here in the rightmost column shows the percent of each of those parts of the corn plant that they contribute to the total amount of residue that's in a cornfield. So the husks and the leaves, which are the most nutritious parts of the corn plant, residue, make up about 40% of the total residue. Okay, and that's the part that we want the cows to be consuming. We want to set our stocking rate appropriately so that the cows are eating the leaves and the husks. And what happens when, because of the difference in the nutrient content of the parts of the corn plant, the cows are really selective, and they first eat the most nutritious, most palatable parts of the corn plant. So when we first turn cows out into a cornfield, the first thing that they select are all the down ears and whatever grain that they can consume. Okay, so initially their diet quality is really high. Next, they eat the husks, and then when the husks become less abundant, they start eating the leaves. And if we leave them in the field long enough and force them to, they'll eat the cobs and the stems. Okay, and so obviously it's not strictly each one of these. Certainly cows will eat some leaves before all the husks are gone. But for the most part, this is the order that the cows prefer the different parts of the corn plant. Because of that, what happens is we get this change in the amount of nutrients that the cows are consuming over time. So initially, when we first put the cows in the cornfield, the diet quality is high. But over time, because they are selecting the more nutritious parts, they're not there for them to select anymore, the diet quality declines. Okay? And I think one thing that becomes obvious is that the rate at which this decline occurs is a function of the stocking rate. Okay? So how many cows we have per acre of corn residue available. And to illustrate that, I'd like to talk about a research project that we're doing at Brule, just west of Ogallala. The university has a center pivot irrigated field there, and what we've done is divided it into 8 pie-shaped paddocks. We have 4 treatments, each of which is replicated twice on the pivot. And the first is a no residue removal treatment. So we don't remove any of the residue, just leave it in the field undisturbed. We have 2 grazing treatments. We have a light grazing and a heavy grazing treatment. The stocking rate for our light grazing treatment is 1 AUM per acre, and the stocking rate for our heavy grazing treatment is 2 AUM per acre. Okay. The way we get that difference in stocking rate, the paddocks are the same size. We turn the cows in on the same day, and we take them out of the paddocks on the same day. So the number of grazing days are the same, and the difference is the number of cattle. So in the light grazing treatment, we use 17 head, and in the heavy grazing treatment, we use 34 head. So we have twice as many cattle in the heavy grazing treatment to get our 2 AUMs per acre. I would just like to point out that the recommended stocking rate for this paddock would be 1.5 AUMs per acre. So our light grazing treatment is below that, and our heavy grazing treatment is above that. These data show the animal performance. Okay, and what I'd like to concentrate on first is the body condition score. You can see that the cows that are at the 2 AUM per acre stocking rate lose body condition, but the cows at the 1 AUM per acre stocking rate maintain body condition. So that's because there are fewer cows in the 1 AUM per acre stocking rate, and that means that the higher quality, more nutritious parts of the corn plant last longer in that paddock. So if you look at the weights, what you'll see is that the 2 AUM per acre cattle gain more weight than the 1 AUM per acre stocking rate. And I think the reason for that is it's just some fill differences. We don't have weighing facilities at the cornfield, so we have to transport them back to the ranch to weigh them. And at the 2 AUM per acre stocking rate, the cattle are forced to eat the less digestible plant parts, and I think what that does is make a fill difference. But I think the important thing is that it's the body condition score change that's important. I also wanted to just talk about the subsequent yields. So while we're on the topic of that research project, I wanted to point out that there is no difference among the treatments in yield. Okay, we've been doing this project for 4 years now. We've started our 5th year in 2013, and we plan to continue it because it may be that it takes time to see these differences, but certainly after 4 years, we don't see any difference in the yield in the field based on the treatment. I just wanted to point out this is a map from the yield monitor at harvest. The field's pretty variable, and I think one of the things we need to do is account for this variation in our research. But I think it's clear from this that there's no consistent differences among the treatment. I just want to talk a little bit about what things do we need to keep in mind in terms of subsequent effects of grazing. Well, one thing I think is really important is soil water balance. And obviously this depends a lot on which side of the state you're on, how big of a deal it is. On the western side of the state, it's more important to conserve water. On the eastern side of the state, we might actually want to try to manage our residue so that we can get the fields to dry out a little bit in the spring, and we can get in there to plant and so forth. So we know that the residue does play a part in soil moisture balance. Residue prevents evaporation, and it also promotes infiltration. So when we get precipitation rather than the precipitation running off, we can more of that water will infiltrate into the soil. Something else I think we need to consider is planting considerations. There are definitely parts of the state where the yields are so high and there's so much residue that it can actually, we need to do something with that residue, remove some of it in order to get good corn stand. And you know, germination and proper placement of the seeding of the seed when planting is all really important, and those things can affect the yield, and residue plays a role in that. So it can actually be beneficial in parts of the state where we have really high yields to graze the residue so that we can have better planting conditions. And Dr. McDonald talked about that briefly, where there have been projects on the east side of the state that demonstrate increased yield as a consequence of removing some of the residue. I think another thing that needs to factor into the decision is what about suppression of volunteer corn? Cows consuming the down ears can really help reduce volunteer corn. I think one of the biggest concerns that people commonly discuss with me is what about nutrient removal? And I'd just like to point out that there's a really big difference between grazing and baling when we talk about nutrient removal. When we bale that residue, yeah, those nutrients are being completely removed from the field. But when we graze, those nutrients are returned to the field. So, and let's take phosphorus as an example. If we have a mature cow on the field, by definition, all the phosphorus she consumes is excreted, and so that remains on the field. I think one of the things that we need to consider is distribution. Cows obviously don't distribute their manure evenly across the field, but I think the key thing to remember is that it's a completely different situation than baling, where the residue is completely removed from the field. One thing I think too that could be considered is plant diseases. We know that many diseases overwinter in the residue. If we can remove some of that residue, we can potentially decrease some of the disease pressure. Another thing that I think is really important is what about soil quality? And so by that I mean things like, okay, soil particle aggregation. We have these water-stable aggregates that get formed, and tillage is important in their formation, and also potentially the traffic from the cattle, is that influencing these soil particle aggregates? And by the same token, what about compaction? And to me, so this is something that we are measuring at our project at Brule, and at other locations we're measuring soil bulk density. What I can say at this point is that the compaction is not an issue. And to me, the most important measure of whether or not we're having soil quality issues is the subsequent yield. Okay, and so obviously the work at Brule is fairly new. 4 years might not be enough time to definitively say that we're not having any of these issues, but we don't, to this point, don't have any yield differences. Dr. McDonald he mentioned a study where it's been ongoing grazing for decades, and there is no difference in the yields there. So to me, that's the most telling and best information to address this issues about soil quality. I wanted to point out this is something that we've been working on quite a bit, and what we did is put together a NEB guide where we've got an accompanying Excel spreadsheet where producers can put a value on all of these considerations. So these things that we've just talked about, from water to nutrients to diseases, all those things can be accounted for in this Excel spreadsheet. And if you go to our website and find our cornstalk grazing NEB guide, you'll be able to access the text and also the spreadsheet to help you account for all these costs. Okay, next I want to talk some about calculating the stocking rate. So we know that the amount of residue available to be grazed is a function of the grain yield. So the more grain that the field yields, the more residue that there will be. And it's been established that there is about 16 pounds of leaf and husk on a dry matter basis per bushel of corn that's produced. Okay. So just to take as an example, if we had a field that yielded 175 bushels per acre, if we multiply that by 16, we can figure that there are 2,800 pounds of leaf and husk on a dry matter basis per acre. Not all of that's going to be available to be grazed. Some of it blows away, some of it gets trampled on, so we calculate that about 50% of that will be available to graze. Okay, so that leaves us with 1,400 pounds of residue per acre. Okay, so that's the supply side. What about the demand? If we say that a cow, the 1,000-pound cow equivalent eats 780 pounds of dry matter per month, well, a 1,200-pound cow is 1.2 times bigger than a 1,000-pound cow. Okay, so that means 1.2 times 780 is 936 pounds of forage per month. And if we divide that by the 1,400 pounds that's available, that works out to be 1.5 months. Okay, so a recommended stocking rate for a field that yields 175 bushels is 1.5 AUMs per acre. That's another way of saying the exact same thing, is that 1 acre would supply enough forage for a 1,200-pound cow for 45 days. Wanted to point out, we've put together an Excel spreadsheet to help calculate the stocking rate. If you go to our website, beef.unl.edu, and click on Learning Modules, that's right here in the top center, that will take you to this page, and we have the corn stock grazing calculator. This is an Excel spreadsheet, and I realize that the text is pretty small, but I wanted to give you a feel for what it looks like. And in this spreadsheet, you can enter into the corn yield, how many cows you have, and how many acres, and it will tell you how many days. Or conversely, you can tell it how many days you want your herd to be on the field, and it will tell you how many acres you need to rent. Okay, so if you, for example, if you want to spend from October until March with 200 head, it can tell you how many acres you would need to rent. Another thing that's really convenient in this spreadsheet, it accounts for other costs, or including transportation. So if you need to truck the cows to the cornfield, and then your costs for care and supervision, all those can be included, and it'll give you a final bottom line. And so it calculates the costs on a per head per day basis, and then also for the total herd. And so it's a really convenient tool that can be really helpful when planning or considering grazing corn residue. I want to talk a little bit about supplementing, weather, and then just modern corn hybrids and how that affects animal performance. These are some data that were collected from the east side of the state. Cows were put on a cornfield during the winter. Half of them received protein supplement and half received no protein supplement. And the stocking rate was 1.5 AUMs per acre. Okay, so that's important that the stocking rate be appropriate. So the cows that received supplement they increased body condition over the winter. Okay, if cows didn't get protein supplement, they just maintained body condition. It's the same story with body weight. If you look at the weaning weight for the calf, there was no difference, and there was no difference in pregnancy rate. Okay, so what's the point? If you supplement cows on a cornfield, they will increase body condition, but we don't get any return for that investment in supplement. Okay, so there's no economic advantage to feeding supplement. In fact, there's a detriment because it costs more than what it returns. And I want to point out these data are with mature cows. So young cows, it's a different story. If we have heifers or 2-year-olds, that's a different story. But with mature cows, if we set the stocking rate appropriately, there's no need to feed protein supplement because we don't receive any economic return from that. I think one of the things we have to consider is the weather. These data show the number of days that there were greater than 3 inches of snow cover for 4 different places. I got just 2 different places in Nebraska and then in neighboring states. And so it does, depending on your location, it really varies how much snow we can get. And it depends a lot also on the year. So from year to year, there's quite a bit of difference. I just want to take, for example, Fairbury to show this, that some years there's 0 days where we have more than 3 inches of snow, and some years there's nearly 70 days where we have snow cover. It's been my experience that most people overestimate snow risk. Cows can easily move powder up to 6 inches deep and do just fine. What's not overestimated is ice risk. Even if we get that snow to crust a little bit, or if we have an ice storm, cows just can't get through that, and so we need to have a plan for what to do when we get these storms in the wintertime. And I just want to demonstrate this. These are the university cows we had on a cornfield near Paxton, and in 2006, January 5th of 2006, it was 70 degrees the day I took this picture. And then the next year, I think it was 10 below on this day. So there's just really big difference between the winters, and that shows in the cow's performance. One thing I want to talk about is eardrop, or we don't have near as much corn in the field with our modern hybrids, but sometimes we can have instances where there's a lot of corn, whether from hail or for example, last year in late October, we had 70-mile-an-hour winds here in western Nebraska, and there was a lot of corn that got knocked down in the field. And in fact, one of the university fields, we estimated we had up to 70 bushels of corn per acre in some parts of that field, and I think that's a real issue. And it's something that we need to be concerned about. So, depending on the severity, how much corn there is in the field, that will dictate what the management practice needs to be to account for that. But so certainly things like cross fencing or adding sodium bicarbonate to the water are things that can be done to potentially alleviate any issues. But that's just something we need to be concerned about. And we kind of have a rule of thumb that if there's more than 8 bushels per acre, that's the point where we need to be concerned about potential acidosis issues. Nitrates usually aren't a problem on irrigated cornfields. We can have problems on dryland fields sometimes. And so I think that's something we definitely want to test for. So definitely in 2012 we had some issues with that, and it's something we need to have in mind when we're considering. Okay, so the last issue I want to talk about is, okay, what about our modern corn genetics with all of our genetic traits that we have introduced in them? Certainly anecdotally, I talked to a lot of people and seen it myself that, cows can find the refuge areas. They prefer the areas where there aren't the Bt traits and the rootworm and even Roundup Ready traits. So I think that's an issue. But the most important thing, I think, is to look at how cows perform even with these genetic traits in corn. And I think these are some data from our research project where we have cows that spend the winter on winter range and cows that spend the rest of the winter on corn stalks. Okay, and so these are contemporary groups. This first column shows cows with that spent the winter on range with 0 pounds of supplement. This group had 1 pound of supplement on winter range, and this group had 2 pounds of supplement on winter range. And we compared them to a group of cows that spent the winter on corn stalks and did not have any protein supplement. Okay? And what I want to point out is if you look at the body condition change, body weight, and then the weaning weight of the calf and pregnancy rates, cows that spent the winter on a cornfield had the same performance as cows that were getting 2 pounds of protein supplement on winter range. So my point is, even with these genetic traits that we have in the corn these days, and yeah, we have less corn down in the field, cows still perform well on a cornfield. Okay? In fact, they perform as well as cows that are grazing winter range with 2 pounds of supplement. And if you look at the cost difference between those, the advantage goes to cows that spend the winter on cornfields. So I think that's the best way to talk about the modern corn hybrids that we have. So let me just sum up. In Nebraska, corn residue is abundant. It's underutilized. By far, the most important consideration to how well cows will perform is the stocking rate, and that's because the different parts of a corn plant differ in their nutrient content. So the leaves and husks are more nutritious than the stems and cobs, and we want to set our stocking rate appropriately so that the cows just eat leaves and husks and don't eat stems and cobs. If we do that, then there's no need to feed protein supplement to the cows. They'll maintain their condition while grazing corn residue. We don't need to worry about, for the most part, any negative consequences associated with grazing. If we set our stocking rate appropriately and graze responsibly, we don't have subsequent effects on crop yield. Our animal performance is really good, and cost alternatives, it's just really economical to utilize crop residue. So with that, we'll just want to mention, if you have any questions, please feel free to contact me. You can call or email.